Okay, so we're going to be simplifying radicals today. It ties into what we did yesterday with the prime tree factor. Some of our vocab words are factors, radicals, perfect square, essential question, how do I simplify radicals that are not perfect squares. So at any time in the video, if you guys want to pause it so you can catch up on writing, just go ahead and do that, because I'm going to try to go through this pretty quickly. So starting with the vocab, factors are numbers you multiply together to get a product. So for example, if I wanted the factors of 10, you would tell me all the numbers that multiply together to get you to 10. So 2 times 5 is 10, and then 1 times 10 is 10. So the factors of 10 are 1, 2, 5, and 10, which are all these numbers. So you're going to hear me say that word a lot throughout this whole year. Radicals, any expression containing the square root symbol. So radicals and square root, that means the same thing. So you'll hear me use both of those words back and forth. Perfect square is a number that has a whole number square root. So some of our perfect squares are the square root of 4, which is 2, the square root of 9, which is 3, the square root of 16, which is 4. So those are perfect squares. So this is kind of an example of the prime factor tree that we worked on yesterday. So I took the number 100, broke it down into any two numbers that multiply to 100. So I got 2 and 50. 2 is prime, so I circled it, and it ends that part of the branch. Then we go to 50, break that down. I put 2 times 25. 2 is prime, so it ends that piece of the branch. And then I have 25, and that breaks down to 5 times 5. Those are prime, so I circle those, and that's when I know I'm done. It's very important to circle all the primes, so please, please, please make sure you do that. Something I kind of wanted to show you guys from here. So the prime factorization for 100 would be 2 times 2 times 5 times 5. That is the prime factorization for 100. Whenever you have repeated numbers, when it comes to multiplication, you can rewrite that using exponents. And so that's where we're going to go with this one. So 2 times 2 is the same thing as 2 squared, and 5 times 5 is the same thing as 5 squared. So that would technically be the answer if we were just breaking down the prime factorization for 100. Now, if I put a radical there, I'm still going to do this process the same exact way. The only thing that's going to change is at the very end, whatever my answers are, those will also have radicals. So this is kind of the time where we learn that the inverse property, or what undoes square root, is squared. They undo each other. And let me kind of just show you on the side how that works. So if we took 2 squared, well, 2 squared is 4. And the square root of 4 is 2. Right? So when you look at square root and squared, they actually undo each other. And there's the answer, which is just 2, which is what we got right here. So square root and squared undo each other. So that means square root and squared undo each other here. They cancel each other out. They undo each other. So now you're just left with 2 times 5, which is 10. And the square root of 100 is a perfect square, and it is 10. So this is kind of the idea that we're going to be using to simplify radicals. Let's see, we're going to skip this piece. So there is a shortcut. Let me kind of show you guys the longer way first, and then I'll show you the shortcut. So if we start with radical 32, we're going to do this the same way. Break it down to any two numbers that multiply to 32. I'll do 8 and 4. And then I get 2 and 2, 4 and 2, and then 2 and 2. And it's important that you guys circle the primes, because those are what's important. These other numbers aren't important when it comes to our answer. Only the primes are. Okay, so 1, 2, 3, 4, 5. So there's 5 of them. So it would be like that. Now, I want to always write this as squared, because if something's squared, I know once I take the square root of squared, it undoes it. So I'm going to take these two and write it as squared. And I'm going to take these two and write it as squared. And then that just leaves me with this last 2. Now this is good because if this is radical 32, that means technically all these are under the radical. Well, square root and squared cancel each other out. So you're just left with 2 times square root and squared cancel each other out. 2. Now this one doesn't have the squared, and so it is stuck under the radical. 2 times 2 is 4. 4 rad 2 would be the simplified answer to radical 32. So this is where you would want to go with it. Let's do one more this way. So any 2 numbers that multiply to 27, we have 9 times 3, and then 3 and 3. So this is 1, 2, 3. Okay, now remember we always want to write something as squared. So I'm going to take these 2 and write it as squared, and that just leaves me with the last 3. Now since it is a square root problem, I'm going to put these under the square root symbol. Well, square root and squared undo each other, so you're just left with 3 rad 3. And that is the answer for that one. There is a shortcut. If you guys like doing it like this and showing all your work, then that's okay. But if you don't, then I kind of have a little shortcut. It's really doing the same exact thing, but just not writing it all out. So these are the steps to the shortcut. So we're still going to find our factors, we're still going to do our tree, we're still going to circle the primes. Now once we have all the primes circled, we can pull out a pair and write it in front of the radical. Because think about it, if it's a pair, that means it's squared. And squared and square root undo each other, so that's what makes it come out of the radical. You just have to remember that if there's multiple numbers that you bring out of the radical, they have to get multiplied together. And if there's multiple numbers that stay in the radical, then those have to get multiplied together. So make sure you have these steps written down. You can pause the video if you guys want to pause it. So I'm going to show you a couple problems using this method instead of the other one. So here we have radical 75. I'm going to break this down to 25 times 3, and then 5 and 5. So the idea is, if it has a pair, it gets to come out. That number gets to come out of the radical. And if it doesn't, if it's single, it stays inside. And that is the answer, 5 rad 3. If you were to do this the other way, it would have looked like this. So you had a pair, so you could write it as squared. But then you would have put the square root over them both, because this is a square root problem. You would have saw that square root and squared undo each other, so you just would have been left with the 5, and the rad 3 stays, which is the same answer. So however you want to do it, sounds good to me. Let's do 30, so 3 times 10, and then 5 and 2. So for this one, I don't have no pairs. So if there's no pairs, you leave it all inside the radical. And at that point, you would make sure you multiply them all together. 3 times 5 is 15, times 2 is 30. And notice that that's exactly what was given to us. So that just means that we cannot simplify this radical any further. Radical 30 is the most simplified version of that answer. Let's do one more. So sometimes you guys will get problems where there's already a number on the outside, and just don't forget about that number. So I'm still going to break this down like normal. So this time I already have a 2 on the outside, so leave it on the outside. I have a pair of 2's, so if it's a pair, it gets to come out. And if it doesn't have a pair, it stays in. And this is going to be 4 rad 5. If you wanted to do this the other way, from here, you would have just said, okay, there's a 2 on the outside, so there's still a 2 on the outside. There's a pair of 2's, so you could write it as 2 squared and 5. And these would go under the radical because they are under the radical here when you do your tree. This number is never under the radical, so it wouldn't have a radical here. And then from here you can see that square root and squared cancel each other out. So you just have 2 times 2, which is 4, rad 5, which is the same answer. So whatever way you guys want to do it, go ahead and do it. That's pretty much all I have for you. You guys are going to get a tiny little paper that has your homework assignment on it. Do not do the homework assignment on this little paper. Make sure you do it on a separate line piece of paper. Show all your work, help each other out, and that's all I got.